Good afternoon, everyone. My name is Jonathan Morin. I'm from the European Advanced Networking Test Center, or EANTC, and I'm here to tell you a little bit about tests we performed together with Spirent. Before I talk specifically about the test that we conducted, I want to just give a little bit of background of the perspective we are going into this test, which defined sort of the scope and the different tests we chose. If you look around the show today, you'll see that a lot of the exhibitors are talking about cloud computing and cloud services, public and private clouds, and what they basically mean are public and private data centers, and the way data centers have been changing. They're sort of experiencing right now a paradigm shift in the way that data centers are built and the way that they're used as a service. And we tried to look at each of these two pieces, and in order to do so, we built our own private cloud, which we have running here, our own data center, and subscribe to several public cloud services. Now, in this presentation, I'm going to be focusing more on the private cloud that we have running here. We actually spent a few weeks at Spirent's lab, us ENTC, together with Spirent, not only building and configuring this gear you see here, but also, of course, running our tests and conducting our tests on it. Now, some of the main aspects we looked at with our private cloud testing is A, fiber channel over Ethernet, and this idea of converged LAN and SAN traffic on our servers, and B, virtualization, and how do these pieces affect my performance, availability, security, and scalability. Right here we have a picture of what our private cloud looks like, and I'm going to be sort of bouncing around to all the different devices under test that we looked into specifically, but it ranges from all over the different pieces of the data center, from the top of rack switch to the WAN accelerators that people are talking about right now, to our firewall. So the first test I'm going to tell you about is a test of our top of rack switch. And the top of rack switch we chose is a fiber channel over Ethernet, fiber channel, and Ethernet capable switch. What we mostly wanted to look at here is how you can benchmark fiber channel over Ethernet traffic. Now, this is a little bit different from benchmarking normal Ethernet switches, because fiber channel over Ethernet needs to make Ethernet a lossless protocol. So how do you measure performance when you don't receive loss? Normally with an Ethernet switch, you basically pump as much traffic you can into the switch until you get lost, and that's where you know where the performance limit is. But with fiber channel over Ethernet, instead they've designed priority flow control, or Ethernet pause frames, to tell an upstream device, hey, slow down, please slow down the traffic before I start to lose frames. So instead of sending traffic until we receive loss, Spirent's proposed a new methodology called qput, where we test the throughput of each queue. They've actually proposed this methodology to the IETF. So in our qput test, we slowly stepped up the fiber channel over Ethernet traffic and the fiber channel over Ethernet queue until we started to get pause frames from the device. And what we saw is basically the device started to peak out its fiber channel over Ethernet performance at about 4.9 gigabits per second. Performance is a little bit less for the smaller sized frames, but that's not only normal because more processing is involved for smaller frames, but it's also less of a concern because fiber channel traffic generally tries to use really large frames. So line rate frames of 128 bytes is not something that enterprises are really concerned about. So the results are quite good, and in parallel to this traffic, we also had a constant normal IP or LAN traffic running on the same links, filling the other 5 gigabits of traffic, and that traffic had absolutely no loss. So at least we were able to see that while fiber channel does have its limit, which is different than what we expected, we do see that this device could converge this traffic. And another test we conducted to see this point is sort of an assumed operation of these switches in their ability to switch from fiber channel over Ethernet to native fiber channel traffic. But we tested it anyway, and we actually have this test running live. We have 6 ports of fiber channel going into 6 ports of Ethernet, and you see the fiber channel over Ethernet coming out. Another test we did is on a device that's getting a lot of attention right now called WAN accelerators or WAN optimizers. And the companies producing this equipment are promising that if you install this device at each of your customer sites, that it will actually improve the speeds of your WAN link. Now, of course, it's not actually going to accelerate the speed of your link, so we chose the word optimizer. because it seems that they mostly optimize which traffic has to be sent over the WAN. And in order to test this, we used the Spirent Test Center to emulate the users, but we also used the Spirent Gem to emulate the WAN. And the way it does that is induce specific defined amounts of delay and loss as specified by the ITU-T's G1050 or TIA 921. And that's a standard that says, okay, it's studied basically different scenarios of high-speed links and low-speed links and defined different parameters for loss, delay, and jitter so that such a device could emulate that WAN scenario. And we said, okay, how does that affect 4 different applications that we emulated with the Spirent? CIFS, Microsoft Data Transfer, Video, Voice, and HTTPS. So for video and voice, which aren't file-based or file transfer-based protocols, we didn't see too much of a performance increase, and this makes sense. This was mostly to be expected since you can't cache video. You have to constantly send whatever video is coming to you. Same as voice. You can't cache what your friend is about to tell you over the phone. But for HTTPS and CIFS, we, in most cases, saw a dramatic increase in performance. Now, we particularly saw this in our area, our emulated scenario of more delay and more loss. This is where the optimizer really came in handy, but not as much for the scenario where we emulated a not so harsh link. So this told us that WAN optimizers can be very helpful for the enterprise, but it really depends on what your use is, what your scenario is, what kind of access you have to your service provider. That's something that they would want to test before they decide to install this equipment. So the other piece I mentioned earlier, virtualization, is something that is challenging enterprises. They're not really sure how to test it. Virtualization, for those who have worked with it, know that this is really unpredictable software and that you don't know exactly how much loss you're going to get from a testing perspective. But to help solve this issue, Spirent allowed us to use 2 of their new products, the Spirent Avalanche Virtual and Spirent Test Center Virtual. And this allows us to put a virtual chassis to test these virtual machines and virtual switches. It's easy to get lost in this whole virtual world, but basically, since you can't have a hardware PC or hardware test equipment in that virtual world, this virtual test gear really helped us out. And the big test we did here is to study how much vMotion or virtual machine migration affects my service level agreement as a public cloud, for example, and out of service time. If I'm a public cloud service like Amazon and Microsoft use, and I'm allowing folks to host their website on my virtual machine, but I'm moving their virtual machine around, they want to know how does that movement affect their transaction. So what we did is we used Spirent Test Center Virtual to talk to a physical Spirent Test Center port, and we moved the virtual machine from one physical machine to another while still sending traffic. And while we made that move, we measured exactly how long do we have without getting any traffic at all. And what this graph shows you is where the traffic dropped off very cleanly and where it came back also very cleanly. And we measured about 1.5 seconds out of service time. For most applications, this is actually quite okay. For video, however, for example, this would be disastrous. So this really tells you, depending on what your needs, this is you can test against whatever requirements you have. And the last piece I'm going to talk about is security. We actually tested 2 types of firewalls. We tested a traditional, quote-unquote, physical firewall hardware. And this is something that enterprises are familiar with since years and years. And we saw that the firewall vendor had down quite well. What we tested is, A, does it block what we expected it to block, which it did, and did that blocking process affect its performance? And what we saw is, no, it did not actually affect the performance, which was a pretty good result for the firewall. But we also conducted the same test on the virtual firewall. What a virtual firewall does is answer the question, how do you block the traffic and the access from different virtual machines within the same PC, in this virtual world created in a single PC? Because that traffic isn't even leaving the PC and will not even go through my physical firewall. So the virtual firewall answers that question, and we actually saw the same results. The virtual firewall blocked everything we expected it to block, and it didn't degrade performance. But we're hoping to make this test. I guess we need to make it a little bit more difficult next time. So what do we conclude from all this? Well, we learned how to test and benchmark some of these new types of devices we're putting in our data center, some of these new virtual paradigms we have installed in our data center. We saw that WAN optimizers are great for some enterprise scenarios, not necessarily for everyone. We saw that fiber channel over Ethernet delivers on its promise to converge LAN and SAN traffic, but its performance is not necessarily what you'd expect, and it's something worth testing before you install it. And we learned that the virtual pieces in our virtual data center are not necessarily predictable and also require some extensive testing. And while we sort of tested across the board here, our scope was quite broad. Our tests were, of course, by no means exhaustive. There's still a lot more out there to test. We like to look into emulating more complex user scenarios, especially in the case of security and the firewall, and see where the limits on these virtual firewalls are. We'd like to see how enterprises are enabling resiliency in their data centers. How do virtual machines affect other virtual machines? These are some of the things we've been talking about testing in our next phase, and there are also suggestions we've got from you guys on the show floor. So if anyone has comments, feel free to come see us afterwards. And that summarizes the presentation. If there are any questions regarding either the public or private cloud tests, feel free to come see me or any of the Spirent personnel here at the booth. Thank you very much.